Merry Christmas! Yes, I have nothing better to do than record a video on Christmas. Well, food comes later this evening. Anyway, I was on YouTube on the main page, which recommends random videos to do, and one was from RedstoneEngineer. He's a member from our Redstone server, so I know him, and I got a recommendation for a video which was apparently the second one. And this one is like a really old adder, and yeah, and I was like, mate, why are you still like building this adder? I don't understand it. So what I'm gonna do is I'm gonna build that adder now and kind of make a video response of what the heck, why this adder, why not this adder especially, like that's the main reason why not this adder. And the other way which I could have done is I could have forced him to rebuild this adder into some more usable adder. Yeah, okay, don't need that anymore. And first, the video. I have seen it, or at least parts of it, and it's fine. There's nothing to say. It's one without speaking, so he can only show what he's doing by actually building it. Oh, that's a nice view for copying. So I'm gonna copy that. Build. It's best. I think it's one of the first adders I saw when I first looked for other adders, but I'm not sure. There had been other adder types at the same time, as far as I know. It's been before my online redstone time, and thus I don't know that many details about it, but I designed the first adder I ever used myself, and that was already smaller than this one, not in terms of compactness. So here we got Stym's Redstone server. I really recommend this server because it's really nice people and stuff, whatever. Anyway, here we are. I am on my plot, and thing is that I'm gonna pick a nice spot like this here, this spot, and gonna build, or let's say gonna copy that adder. This is kind of a bit painful because I have to do this in split view, but once it's copied we can go full screen with this window. So this is a perfect view to copy this build. So first of all, a block with a nice color. Let's take this one. Just gonna build that stuff. And this is, by the way, my second attempt in making this video, because first time I had an invalid access token. Awesome. Yeah, what? Oh no. What happened? Oh, it's Christmas jokes, okay. That is hopefully not a permanent update or stuff, but I think I saw these things before. Okay, so this is kind of a boring part because I'm really just literally copying this thingy, and then I'm gonna take it apart. Okay, so next step is to go up here and connect some blocks for reasons which may not be understood. Okay, so what else to do? There is another block, oops, which should be here, and some wires over here, and I need to place torches here and there, and apparently there's also a torch. Next frame. Okay, so we need block on top, we need a torch over here, and a block on top of that, and a redstone there. Oops. Okay, there we go. So, and then this thing also has outputs. So these are on this side. Only one here, and then gotta connect this like so. Good, now I have lamps here because I can connect them. Let's find more spots for copying. So this is from front. Was it really this? Kind of weird, because I don't recall this part, but maybe it's default for this kind of build? I don't recall. I've taken this one once apart, but once is not enough. I gotta take it apart another time. It's a good training. So I really recommend this exercise which I'm about to do, which is apparently, oh, this seems to be done, taking a build apart and trying to explode the logic behind it, especially if it's this build. It's super nice to explode. So this one works. 1 plus 0, 0 plus 1, this works. What about 1 plus 1? Okay, seems to work, but where's the output? I'm quite unsure. Where it has to be? Maybe this? Let's hope so. And then this is the input. So apparently it's like this, I guess. So let's confirm this again. It's off. I intended to destroy that. So this seems to work still, and if I turn on both, that's on. Okay, perfect. So that's the carry out. I'm not gonna explain how adders work in this video, because that's something you can learn on this server, for example. This is not correct. That's the wrong result, because this gotta be only that lamp over there. So the question is, why is this one on? Well, when it should be off, and I don't know, because I don't understand this yet. Okay, here we go, the carry. And that's a bit problematic, because oh, now he builds it again, so I gotta keep do a bit more attention thingy to know what is going on, why it's not working properly, and I don't know. Maybe I need to put like a torch there or something. Indeed, you see it there. It's I was just pointing at my monitor. Perfect. So it's got to be here, and then that output is off. Perfect. So the same thing with the other one, and then all of them together works. So I just declared this is working. Okay, the point is why I dislike this kind of thing, thingy. First of all, it's super difficult, in my opinion, to understand like what is going on there. And the problem is that if I go and say I want to have an 8-bit machine, that machine is this wide. So okay, time to go big screen. That is apparently way too wide for like most builds, and what you actually want is to have at least a stack width of 4 blocks, in the best case 2 blocks, but let's first start us go with 4 blocks, because that is like the beginner width, and this is like just massive. Just don't do that. Okay, so enough talking, enough, cannot say that word. Anyway, let's just get right into it. So the point is to take this apart, to explode the logic behind it, to understand what this actually is, because it's a normal ripple carry adder, and what I'm trying to show here is that this logic behind this thing is exactly the same as the one which everyone should know already when he has built a 4-wide. So how to start with such a build? First of all, it would be nice to have a copy of it. I can just say stack, and there we go, the copy. Point is, I got to take this apart now. So there's a bunch of connections which we have to keep in mind. Of like this torch powers that block, which powers this, which powers these torches and stuff. That's kind of difficult to take apart, in my opinion. So yeah, the last time I did that was kind of more easy, because I knew where to start. I never know how to start this, which is a problem. I think the first thing I did was, or the first thing one should do is to explode it in this direction, because then we got more space to work with. Which is also a simple change. What we basically do is we just take this and push it a bit further away, like so. The point is that this can be done, and one just expands these blocks to have the same logic as before. The only thing which is still missing is like this connection. So this doesn't help us understand it, but at least it's like a little bit bigger than before. That's the point where you should actually test if things are still working as expected, and that appears to be the case, which is good. So what else to do? This is actually just a puzzle game which I'm doing here. So if you're wondering what I'm doing, it's basically puzzling. I'm trying to move things around until they fit. Yeah, and that is the whole game. So looking at this, one can say that this here should also power like this and this wire, and then I can technically remove that one, but not this one. However, I'm able to move this torch because I just moved that torch over to here. I can also use that torch and move it, for example, there, and do something ugly like that, at least to get rid of that block. So these two are kind of connected, and the point is that this wire over here, which I'm looking at, is, oh gosh, I just noticed I don't have my resource pack on. That's total no-go. Where's terminal? CD, Dropbox, Minecraft programming, full, MC launcher, game directory? No, data, game directory, what was it? Game data, and then resource pack, and then I'm just gonna make a do this, and that's it, actually. There we go. Yes, I still want to use this incompatible resource pack because it's finally perfectly compatible, actually, with whatever it used to be. I need this resource pack because the other ones are, well, the default one is like not so my style. And I said when I make the next YouTube video, I'm gonna use this resource pack because why not? So okay, have a look. That is how it's looking now. Same connections, but like a lot more bulky. And 3D hitbox size. Okay, time to go on. So this torch basically just goes over to this wire. So what we could do at this point is we redirect it and do something, I would say ugly, like this. I would just take this apart or away, out of the way, and connect this like so. This has the same effect, and the point right now is just to explode the logic. Why is this? Oh, it's the connector because of this. So I'm gonna move these here because then I can get rid of this ugliness, like so. So this is basically the same circuit, and we reduced the whole first part by accident or by just messing around to two connections, this one and that one. Let's have a look at what these two do. So one is on, then that one is on, the other one is on, then this one is on, and if both are on, I said on, not off, then the top one is on. So this is basically just a bulky type of half adder. Half adder consists of an AND gate, which is the output on top, and an XOR gate, which is this output at the bottom. And yeah, this is basically it. So what one could do at this point is we move this wire like so. This is one possibility, but we could also like put these blocks here on top to get rid of the torches below. So now we have this type of thingy. Yeah, I think that is already nice to look at. And what we could do is like do this and also put this one level up. I'm just gonna do this to keep this separated from each other so you can see the functionality. So this wire on top is actually just an AND gate, and now I wished I would have written a plugin for the server which can rewire blocks, or like not rewire but at least recolor. So there I say I select this and this block, and then I say turn this blue or something. However, this is also AND gate, and that means that when this is on, this goes off, and that means this one goes on, which is just a simple OR gate or so. Then if there's an AND gate, this goes, the output is blocked. So what does that mean? It means this is still a simple XOR gate, so it means nothing. However, this block is obsolete by now, so that means we can remove that block. So this looks a lot more, I don't know, it looks as ugly as before. Not gonna say anything about it. Okay, there, I think we should take apart this thing now. If someone already has a good eye, he might notice this part here, because this is like already the same thing as in a good version, just the other half is not. But we're gonna take it apart in a proper way, so that it's easy to understand what is actually going on, or like how to take this apart properly. If you have a look at this, this is just an OR gate, so this output is just ORed together by that torch and that torch, because these wires are only connected to these two torches. So I'm gonna move this a bit for simplicity and to get more space. So that's the only reason why I'm doing this. Like so. And now I gotta think about how to continue this improperly. This torch powers that one on top, and this torch powers that wire. So what is possible to do is I could like wire this up in a way that it actually is also quite ugly, but still kind of moved, so that we have less functionality on this torch. I can remove that and get more space over here, which is good for what I want. This is another AND one, and if you wonder when this happens, that can only happen when one output here is on, like when one from the back comes and when there's one from this side, and then this one is on, because then there's a carry, because 1 + 1 is 2. And all the levers here have the value 1. I should maybe make a tutorial for adders at some point. Well, let's not. Yeah. Well, I'm just gonna rewire this to get space. I have a rough idea of how this should look at some point in time, but I didn't know I should continue by now. So one thing I could do is I can stretch this apart or further away from each other, so that I just say, hey, let's put this block here instead, and or let's say here. What does that mean? It means that I need to put some wires here, because that is the connection from here, from this torch to that block, and the other connection I need is the one from this block here, which goes directly to here. So I just moved stuff again to get more space to have a better overview of what actually happens. And this torch could be, for example, there now, because it was connected to this stuff on top, and so that's still connected by now. What else to do? It kind of would be nice if we could flip these two, that this block is on this side, but for that we need to move a bit of stuff, and I think I'm gonna do it like this. First of all, I'm gonna move this a little bit further away again, like so, same functionality, but the point is I can now take this wire and go like this, so that I have this block with the same functionality as this one. I'm a genius. Okay, there we go. Destroying blocks I need. What has to be done here? I need to power this one according to that block. That would be this connection. This redstone to there is now moved to this redstone to here. Same wire. And the other thing this redstone torch powers is this block on top, and this block on top, tongue twister, powers the wire on top over here. So okay, this is now really ugly, but I can do this, and then I can get rid of that and this connection. What to do next? We have this torch over here which powers this block, but we could move this all the way until here, because it's the same connection, same wire, and it goes to this wire still. Now we can remove this, and some people know it already, what I'm trying to aim for, because they know how the thing looks like, which I'm aiming for. Okay, so connection to output still preserved or something. Point is, I can now move this torch here and then compress a lot of stuff again and move things around. But now we have two more or less units, this one and this one. Let me compact this a bit because it's like really ugly this way. I'm gonna move this one just one block further to the right side, and keep in mind I have not touched any of the logic yet. I just refactored wires. I did not do anything else. I'm gonna put this wire here and this one here, and yeah, I think I'm gonna go for the same pattern over here, which is we're just gonna do this instead. You see this? And what I can do now is I can just take this construction here and also move it over here. Like I just moved this torch back to here, which means this connection is now obsolete because it's here, and the connection from here to top is now obsolete because the connection is from here to top. So I can also remove this. I just have to connect this again, and there we go. So now we can compress this a little bit more if we connect the wires on top, like so. Oh, this is kind of a bit ugly, but I'm gonna move it like so. And now we have this kind of thing. The point is that this wire here is has kind of a dual use. The point is that we power to it onto via these blocks, this one and like this block and that block, these two. These are getting powered, so powering the redstone on top. But the redstone on top is also powering the torches below, which is kind of mind blown. But once you understood that kind of principle, it's easy. The same happens here, by the way. Or we can use the same effect over here, which is we use the torch and move it over there. We just move the torch over there because this redstone is getting powered by this block, but this redstone is also powering this block passively, obviously. Which means this is an equal build. These are off, and only if both of these are on, the top wire is off, because then none of these two blocks are getting powered, and so these two torches can be on. Well, basic concept of an AND gate. What else to do? I could move the block on top, like I did here, it's on top, or I just leave it here and just compress this a little bit more. Point is, this is kind of an interesting constellation. Everyone should know this kind of adder which we have, or not adder, XOR gate. It just looks like this. This redstone is getting powered by both blocks, but this redstone dot is also powering both of the blocks. So this works fairly well. And point is, we can just put the output attached to this block, which works perfectly well. We can just put a wire and it connects to this, and if the AND gate triggers, okay, let's do it like so. If the AND gate triggers, the AND outputs are on. However, that is not the case, but we got an AND from here, and we're gonna do the same to this one. For that, I'm just gonna move this again, so same procedure as before. Oopsie doopsie. We got this. And turn the torch over there and do it like so, and there we go. I just moved everything a little bit to the left side, and I'm gonna do the exact same thing on the other side, which means a lot of block breaking and placing and getting the same effect. And as you can see, the whole thing becomes a little bit thinner. By the way, this is a no-go. For this to work, the wire has to be directed to the blocks or on the blocks, else it won't work. But if it's just a dot, it works just fine. So we can, for example, grab the carry from here. So, whoop, that's it. The whole thing grows a little bit in height. Then that's it. It becomes a lot thinner, and we can even make it more thin. And this is a build which every redstoner should have seen before. It's the most basic XOR gate with an AND output, thus it's also a half adder. And remember, the half adder was almost as big as this before. Like, this whole part here in front is a half adder, and this is like 1, 2, 3, 5 blocks wide plus one space for stacking, and this is much thinner. It's 4 blocks by default, and then you can already stack it, and 4 is the target which we want. But we can get it even smaller. What we're gonna do is we're gonna put this block here like this. We copy it over here because then we can also get the AND gate from here, and that means we can grab the carry from right on top the normal output, and that means more thin, more compressed, and that's good because we want that. fun fact, we can put the torch over here, which means we can grab the carry from here. Sounds a bit obsolete. It is. What we're gonna do is we're gonna move this like so, get rid of this part, and then move this XOR just a bit back. What means XOR? This half adder. And that is 2 blocks. Like so. There we go. So now I need to readjust this wire, and then everything's cool. And I can actually move the lever too, because more pretty, more compact. As you can see, this has become quite small. I can assure you that it's still working, but let's give it a try if it's really still working. First of all, I'm gonna move this wire because more pretty. Okay. As promised, this one works, and as you can see, the normal single output is on. On top we got the carry out, the AND output, both off. Then we have one over here, which goes to the single output of the second half adder. If both of them are on, we got a carry, and if both here are on, we got a carry over there again. And if 2 are on here, we have a carry in the first unit, and thus the single output in the second unit. So this works quite well. But we cannot really stack this. Well, we can, but we would have to move this like so, and this is like this would be 1, 2, 3, 4, 5, 6 blocks wide, and whoa, we go nowhere. But no problem. No problem. We got this spot here. It's unused. What we can do is we can just move this up here and put a block there so that these don't connect. Oopsie doopsie. And have the input for the carry in on the side now, on the same height as the output, which is great because now we can just do things which are sweet, and that is stacking. As you can see, the only connection here in the free spaces look identical, which is exactly what we need. So let's give it a try and let's stack it. To here, some blocks, and stack 7. There we go, and this is much thinner than what we get when we have this. Obviously it's longer, but you can even make this one shorter with not many edits. I could also show this, but I think the video is already quite far, and all I wanted to do in this video was to have a little bit fun converting this one to that one without touching any of the logic. Like, I literally did not touch any of the connections here. I may have merged some torches or splitted them apart in two, but the logic is identical to this one. And if you followed the video properly, then you may have noticed that. So, if someone likes to have a challenge, I recommend to like take this apart, to explode it, and to compact it again to something like this. It's tricky. There's another nice challenge regards that, which I could show you another time. Okay, well, that's basically everything I wanted to show. What you can do when you want to get this smaller is you take the second half adder cascade and move it one in that direction, so that you don't have this corner here, that the output goes straight into this half adder, and that these two carry torches are also opposite to each other. That gives you a lot of advantages in terms of compression, because then you can move this half adder one further in this direction, and the whole thing becomes one thinner. And now let's count this one. It's 1, 2, 3, 4, 5, 6 blocks long, and this one is a lot longer. Assuming we compressed it properly, 1, 2, 3, 4, 5, 6, 7, 8. So it's 7 after compression, and this was 6, was it? 1, 2, 3, 4, 5, 6, yeah. So it's just one longer and not really higher, but a lot thinner. So recommend use this version or the one which is even compressed a bit more. I can make a video about that if you want to, but it's just like I explained nothing. All I did was converting logic. So have a nice Christmas day. If there are questions, just leave a comment in the box, in the comment section, or contact me on the server, or mostly online, or on Discord, however you like. And yeah, I think that's it. Bye.